Station of the Astronomical Society of Victoria with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on the prime frequency of 3541 kHz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3RTV Digital Channel 1. Good evening to viewers there. We're also streaming on my two HD streams, Discord and my YouTube channel, VK3CSJ. Just look for the live indicator. As I normally say every Friday, Discord is probably the better way to view the visual side of this broadcast, from the point of view that there's less than a second delay from what you're hearing from me on the band on HF and what you're seeing on video. Whereas with YouTube, it's anything up to 20-second delay, if you can be patient enough with that. Anyway, we're broadcasting there on Discord in my HD stream. If you register on Discord, I supply a universal link on my qrz.com page, VK3EKH as well as VK3CSJ. I provide a link which will allow you to get to the Astronomical chat room, which the video channel is associated with as well. Anyway, there it is. We have a few things tonight, but I don't know. Well, I say this every week. We'll probably get it under 60 minutes, but as usual, usually get it up to 60. Anyway, if it's less than an hour, that'll be fine by me. I'm having troubles with my YouTube downloader. Two things happened this evening. There was an update on Windows, and of course this blasted YouTube downloader that I use, which is generally successful in most cases. Almost every second or third week there's an update, and you've got to download that. You don't have to, I guess, but I do anyway. So this recent download only a few moments ago has prevented me from downloading YouTube videos. I don't know why. Something's going on. It's telling me to choose a better resolution, so I've been fiddling with that, and it hasn't made any difference. So I'm not sure what's happening with the YouTube downloader program. Whether it's that or whether it's the update that Windows has done, I don't know. But I'm going to have to find out the reason for that, or find another way of downloading YouTube videos, because I'm always doing that. So fortunately, there's no actual video YouTube stuff that I need to show tonight. Actually there was, but that's when I found I had a problem. And what's interesting is, and I might just mention that off the top, the ASVs has a section out of its 20 odd sections. It has one section called Space Exploration, and that's run by Kate Green, and that the information that comes out of the Space Exploration section is very, very popular on Facebook. Kate's very, very busy in keeping that particular Facebook page popular with articles. I think she probably averages maybe 5 to 10 articles a day on that particular Facebook page. It's a real source of amazing information about things to do with space and astronomy and everything in between. So good on you, Kate, for really working well for that Facebook page you do. It really is quite an amazing contribution to the ASV, Space Exploration Astronomical Society of Victoria. 92 members it has at the moment. It's a private group. So anyway, what was I getting at? I've lost my train of thought now. But there was an article on there which, what was it? Where was I heading with all that? Oh yeah, here it is. Kate has promoted a trailer on YouTube. It's called Sally, and it's Sally Ride, who's a NASA astronaut. And this particular video is just a trailer at the moment, I believe. It's just the official trailer. Sally Ride's journey wasn't just about reaching for the stars, it was about breaking barriers and redefining what's possible. And the Sally YouTube film offers an exclusive glimpse into the life of the woman who changed space travel forever. And that premieres, according to this, it premieres on June 16 on National Geographic TV. This is the first I'm hearing about it. It was streaming the next day on Disney Plus. So the trailer on YouTube, you might want, it only goes for a couple of minutes, and I was going to try and screen that. I was just going to quickly download it and screen it for your benefit, if you're interested in that sort of thing. But I couldn't download the blasted thing off YouTube, so I don't know why. Anyways, so yeah, Sally Ride, a NASA astronaut. And if you stream Disney Plus or the National Geographic TV, you'll be able to find that documentary. I don't know how long that actual documentary goes for, but I would say that it'd be worthwhile. It's interesting. That's dated May 2 this year, so that's been promoted for quite a while. Although Kate's put the ad up for that, if you can call it an ad, on August 14. So there it is. We'll just plug that. Now, before I go on, the usual blurb about the ASV, but I'm going to do an experiment tonight, and this may become fashionable for me to do. I'm exploring a little bit of AI technology in as far as artificial voice. Everybody's doing it. Why not me? Gives me a bit of a break. But I just a short while ago, I experimented with that. Something called VoiceOver, I think it's called. You upload the text to a website and it comes back to you. Anyway, so what I'll do, I'll play this audio file together with some vision. So I'll bring up this flying over the world view that I have here, and then I'll run this audio text. This one here, I think it is. No, I think it was that one. I hope I'm picking the right audio file here. Anyway, let's hang on a sec before I do that. I better make sure that it's coming out on Discord as well. I've got to select a particular button for that. In fact, I'll select, there's two audio files I've got here tonight. So that should work. And if everything's okay, I have to press a button on the mixer for this to work too. So the complexity of it all. Stand by and let's see if we can get this bit of a fill for the ASV Society.
Our atmosphere is responding differently to solar storms.
The ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities, and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors, and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, Morley Community Village and the Melbourne Observatory, and we host monthly astrotalks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our astrotalks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the calendar for details if you are interested in attending one of these events. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope and are also currently working on the installation of a series of remote telescopes at our dark sky site, which once complete will be accessible to our members for use. Thanks to a generous donation from one of its most long-standing and respected members, the Leon Moe Dark Sky Site, located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the Leon Moe Dark Sky Site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our Members' Night held once a month at the observatory. An annual yearbook is supplied to members, as well as a bi-monthly newsletter, Crux, which all members are welcome to contribute to. The ASV's logo shows the Southern Cross and pointer stars. Its motto is Sic iter ad astra, which is translated as This Way to the Stars. The ASV is governed by a set of rules which should be read before applying for membership.
Very interesting how that comes across, apart from the American twang to it. I'm sure I can find another voice for that. But thanks to the artificial voice generator, who comes across as Illinois, I don't know, some funny name she's been given. But anyway, I've got an article a little later on, in a short while or two, which is another female voice, but it's one of the articles I've decided to convert the entire text to this speech, and I had to listen to it, and it doesn't sound too bad actually. The artificial voice generators do very well these days, I must admit, and the pronunciation, of course, is perfect well, at least I think it's perfect. So if there's any, believe you me, if there's anything that's got some screwy text in it, or pronunciations, particularly people's blasted surnames, I'll be using that with the voice synth, because I'm just about over it. All right, I think I got the gain. I'm just making sure I've got keeping the gain in control here for everything. All right. It still seems to be too loud for YouTube. I'm just concerned that I'm overdriving the level for YouTube, so I'll knock that down a bit. 1, 2, 3, 4. Yeah, I think that's okay. So I think that turned out okay. All right. So welcome anyway to everybody to this session tonight. This what is the date? 22nd of August, and very rapidly coming up to the end of the month. And I think, if I get it right, yes, it's yes, there will be a broadcast next Friday, but next Saturday is the ATV QSO party, and that's all day Saturday. Usually the ATV QSO party occupies a Friday night, and that would mean not doing the ASV broadcast. But I think the last 2 years the ATV QSO party has been focused pretty much on a Saturday only event. So kicks off at around 10 o'clock Saturday morning with crosses to America and the local lot here. And then later in the evening there'll be crosses to England, and I think the QO 100 satellite, I can't remember, it's something 100 satellite, Q's 100 satellite, which is that geostationary satellite that they've got up there in the Northern Hemisphere, will be used as well, which was successful last year, if I remember correctly. But anyway, that's enough of that. I'll mention it again next Friday. All right. Now, the first article I have here to talk about. Oh, also, although I can't show anything, unfortunately, there was another meteor that burned in the sky this morning, at about 4:40 a.m. There was a entry in over the Narre Warren Cranbourne area, and there is video of it, but downloading video off Facebook is a bit of a trick, and I have been successful with it, but it did require a bit of filling around, but I've just run out of time. So I'll see if I can fix that up for next week. But yeah, there was it was bright enough to, as it exploded, it lit up the surrounding cloud. And actually, I wonder if I could. Oh, it's too much mucking around. I was going to turn the camera around to the computer screen. That's probably the easiest way of doing this. I wonder if I can do it. No, I won't do it. No, it's too difficult. Too much mucking around. Suffice to say that yes, there was another fairly decent meteor entry last night, 4:40 a.m. and the the security camera footage really does pick it up nicely. So there's just a little bit of an update there, I guess. What next? Last Friday, although this article didn't, I didn't notice it last Friday, courtesy of Astronomical, but last Friday, the 15th of August, I think that was the date. Let me just check my calendar. Yeah, last Friday. Okay, we're celebrating the anniversary of the WOW signal. And let me just bring up that traditional image that everybody has seen. So last Friday was that anniversary of that, and today, going by the article here, today in the history of astronomy, ET is calling, maybe. It's only a very short article. On August 15, 1977, a narrowband radio signal was detected by the Big Ear radio telescope at Ohio State. Ohio, that's it. The signal was powerful, and it lasted some 72 seconds and was picked up on only one of 50 possible channels that they were using. It also showed a distinct pattern, starting low, growing and then decreasing again, suggesting it was passing over and therefore had a celestial, not earthly origin. A few days after the signal was received, astronomer Jerry Eman spotted it in a computer printout of data and jotted it "wow" in red ink next to it, which has now become famous. So, what was the WOW signal, though? Astronomers still aren't sure. The SETI Institute conducted follow-up investigations, but the phenomenon has never repeated. Despite some characteristics that might suggest it was a signal from extraterrestrial life, that lack of repetition is an argument against ET, and more likely it was a natural astronomical event that we lacked the necessary tools to analyse in 1977. Theories continue to be evaluated, including a recent paper proposing that it was the result of a flare from a magnetar interacting with a cold hydrogen cloud. No one could ever have guessed that in 1977, and of course magnetars weren't even suggested until 1992. So yes, August 15, 1977. So that's a pretty interesting event, and I think there's I've got a book that's based on the Big Ear radio telescope, which is no longer around. It was dismantled, unfortunately. But there it is. Imagine seeing that as a technician and looking at that and understanding what those bunch of letters meant. Oh dear. Anyway, there it is. All right, so you're tuned to ASV Radio, VK3 Echo Kilo Hotel, broadcasting on 3541 kilohertz, the Melbourne television repeater, VK3 RTV, digital channel 1 in full HD, and on my stream, Discord stream and YouTube stream. We have an email address too if you wish to send signal reports and the like, vk3ekh@gmail.com, vk3ekh@gmail.com. And let me just check Discord, and I can see that we've got Andrew VK3KIS there, and g'day Mitch VK3ZT. Welcome, welcome, welcome. And I think my email address is set up. Yep, Andrew's checking in there as well. Thanks, Andrew, for the report. Righto. What next have I got here? Oh, yes, this is something I just found. Okay, this will be a bit lengthy, but potentially interesting, because I did vaguely remember something about this. Still sticking to the theme of meteorites. First recorded human meteorite strike, still a wild tale, 70 years on. Courtesy of space.com, published 18th of August. Anne Hodges never intended to be famous, but in 1954 she found herself thrusted into the national spotlight when her afternoon nap was interrupted by a falling meteorite. The Alabama woman has the distinction of being the first documented case of a person being struck by a meteorite. She survived with a very bruised hip. Take a look at this. I haven't seen this picture before. Look at that. That must have hurt. That must have hurt. In June, a man nearly joined her exclusive club when small space rocks pierced his roof in McDonough, Georgia, missing him by 14 feet, the New York Times reported. The fragments from a meteorite that researchers say likely formed 4.56 billion years ago dented his floor instead. In the more than 70 years since Hodges was struck, her strange tale remains a source of fascination. Mary Beth from Alabama Museum of Natural History, where the meteorite is on exhibit, told Business Insider it's one of those local legends that not too many people know about, it seems. And here's what happened to Hodges and the meteorite. And there's a picture here I've got of the hole in the roof. Let me go back to vMix. So this is this is the hole in the roof where it came through. Here's what happened to Miss Hodges. The meteorite, which is also called the Hodges meteorite, probably broke off the asteroid 1685 Toro. How they know that, I don't know. 1685 Toro, a mid-sized asteroid, has been classified by NASA JPL as a near-Earth asteroid because of its orbit's proximity to Earth. Its size is similar to the island of Manhattan, and there's a picture of it here actually. Where are we? There it is there. It's truth. An asteroid is a rocky object in space that orbits the Sun. When an asteroid or a piece of one enters the Earth's atmosphere, it becomes a meteor. What remains after the impact is a meteorite. And the picture on the screen is part of 1685 Toro, which hit the woman in the 1950s, the article says here. So on the afternoon of November 30, 1954, locals in Alabama reported a bright streak in the sky. At a time when both the threat of an atomic bomb and little green men flying in saucers invaded public fear, it was perhaps unsurprising that the residents in the small Alabama town started calling 911. The Decatur Daily newspaper reported that many people thought that they were witnessing a plane crash. And Hodges, with her husband, rented a house in Oak Grove community. Incredibly, across the street was the Common Drive-In Theatre. That's interesting. So I'll just repeat that in case you didn't get that. So where they lived, Anne lived and was hit by this meteorite. Just across the street was a theatre, a drive-in theatre, which was called Comet Drive-In Theatre, which had a neon sign depicting a comet falling through the sky. That's interesting. A part of the meteor crashed through the roof of Anne Hodges' home, and I've got another picture, a close-up of this hole. Sorry for interrupting the story, but there is a close-up of the actual hole. You can actually see light coming in through the roof. So, pretty amazing. Imagine that happening, hey? Hodges, who was 34 at the time, had been home with her mother on the afternoon of November 30. The meteorite crashed through the roof of Hodges' home at 2:46 p.m. Anne Hodges was taking a nap on her living room couch, and she was under a blanket, which probably saved her life somewhat. The meteorite came down through the roof in the living room, and it ricocheted off a standby console radio a stand-up console radio that was in the room and landed on her hip. So she wasn't directly hit. It was a ricochet off the console radio. Good old radio, saved the day. Her mother, who was in another room, ran to her daughter's assistance when she heard her scream. And in the aftermath, neither Hodges nor her mother knew what had happened. All she knew was that something had hit her, and they found the meteorite, this big rock. They couldn't figure out how it had got there, and it weighed in at 8.5 pounds. And we have a picture of it here. There it is. Bring it up. There she blows. So that weighs 8.5 pounds, probably around about, 16 kilograms. So Miss Hodges said that the meteorite is a chondrite, or a stony meteorite, and composed of iron and nickel. According to the Smithsonian magazine, the meteorite is estimated at 4.5 billion years old. When the meteor entered the Earth's atmosphere, it broke apart. One fragment hit Hodges, while another was located a few miles away. A farmer, Julius Kempis McKinney, discovered the second fragment while driving a mule-drawn wagon, and later sold it for enough money to buy both a house and a car. The Decatur Daily reported. Neighbours and law enforcement rushed to Anne Hodges' home. Before you knew it, everyone in town was surrounding the house wanting to see what had happened. In those days, they didn't have Facebook, of course, but word still travelled pretty quickly. A doctor and the police were called to the home, and the mayor, Ed Howard, and the police chief who discovered the hole in the ceiling where the meteorite had crashed through. The Decatur Daily newspaper reported the impact of the meteorite left a large grapefruit-sized bruise on Hodges' hip. She had this incredible bruise on the hip, told the Business Insider. She was taken to hospital not because she was so severely injured that she needed to be hospitalised, but rather because she was very distraught by the whole incident. and she was a very nervous person, and she didn't like the notoriety. Oh God, all the people of having all these people around her. Hodges and husband Eugene arrived home from work to find his house surrounded by a crowd of people. Hodges' radio may have saved her from being seriously injured. The fact that it came through the roof that slowed the trajectory, and the fact that it bounced off the radio, if she had been lying under the radio, it would have broken her leg or her back. Why would she have been under the radio? It probably would have killed her, but would have done a lot more damage to her if it had been any other way. The Air Force confiscated the meteorite so that it could be determined its origin, and the Air Force looked at it because they thought it was a flying saucer and all this other wild and crazy stuff. After it was confirmed a meteorite, the Hodgeses faced a lengthy litigation process to acquire ownership of it. Their landlord, Bertie Guy, believed that the meteorite belonged to her because she owned the house. Suing is the only way she'll ever get it, Hodges told reporters at the time. I think God intended it for me. After all, it hit me. The Decatur Daily News reported Guy wanted money to fix the house's roof, and the litigation went on for a year. And the guy settled in the case for $500, and the house eventually caught fire. Oh dear. The house eventually caught fire and was demolished to make way for a mobile home park. Hodges became an overnight celebrity and was even featured in a game show. She became famous for 15 minutes. She had all these photo shoots. She was invited to go to the New York City to be on the Gary Moore show, I've Got a Secret, where the panel had to guess what her profession or what happened to her and why she is a notable figure. Hodges would receive fan mail from churches, children and educators asking about the meteorite, but she never answered any of them, leaving it to her lawyer. She was a very quiet person. She was a very private person, and she did not like having all the notoriety. Hodges decided to donate the meteorite to the Alabama Museum of Natural History, which is that on the screen there. By the time she had got the meteorite in her possession, she was so sick of the whole thing, she said, "You can have it." All Hodges asked in return was for the museum to reimburse her for the attorney fees. And the meteorite created problems between Hodges and her husband, Eugene. Her husband wanted to make money off the meteorite but failed to secure a buyer. Unbelievable. The two eventually divorced in 1964. In 1972, aged 52, Hodges died of kidney failure in a nursing home. 1972, and she was 52 years old. Hodges is the first documented person to have been hit by a meteorite. Recently, a man in Georgia narrowly missed being hit by another. It only happens in America. She's the only one who ever has been hit by a meteorite and lived to tell about it. Because of that, meteorite has been appraised as at over $1 million. Because of that, the meteorite has been appraised at over $1 million. In an interview with National Geographic, Florida State College astronomer Michael Reynolds said, "You have a better chance of getting hit by a tornado and a bolt of lightning and a hurricane all at the same time." There have been some near misses in the years since Hodges was hit. Most recently, on June 26, people in southern states reported seeing a fireball fly across the sky, and pieces of a meteorite hit a house in McDonough, Georgia, with some piercing its roof, denting the floor and missing the residents inside. He likely heard what sounded like a gunshot He says, I suspect that he heard three simultaneous things, said Scott Harris, a researcher at the University at George's Franklin College of Arts and Sciences Department of Geology, the university reported. One was the collision with its floor, one was a tiny cone of sonic boom, and the third was impacting the floor all in the same moment. There was enough energy when it hit the floor that it pulverized a part of the material down, literally dust to dust fragments. Harris studied the rocks and concluded that the meteorite could have formed 4.56 billion years ago, making it older than Earth. It is still being studied at the university. Every day, Earth is hit with more than 100 tons of space dust and debris. According to NASA, about once a year, a car-sized asteroid enters the Earth's atmosphere, but burns up before it can touch ground. One expert told Live Science that while it's impossible to know for sure how many asteroids hit Earth each year, he estimated about 6,100 meteorites fall per year over the entire Earth and about 1,800 over land. And of course there's a picture here of the most famous crater, of course, Arizona crater. Come on, bring it up. There we are. We've all seen this guy. Most of these go undetected, but occasionally they'll capture the public's attention, like Hodge's meteorite. For instance, in 1992, a 26-pound meteorite landed on a red Chevy Malibu, I think that's a car, Malibu in New York, and in 2013 one exploded over Russia. There has also been evidence of a meteorite killing a man and injuring another in 1888. Meteor crater on screen right now, which is almost a mile wide in Arizona, shows the impact of a large meteorite can have. Beautiful, eh? So the Business Insider, the years since Hodges was struck, her story remains popular, and people have contacted the museum about using the story in movies. Oh dear, plays and even graphic novel. Can you see that being dramatised? Anyway, so there it is, and I'll go back to the initial bruised picture in case you missed it, but there it is. There's her massive bruise on the side of her body there, poor girl. Not good. I don't think she would have liked that picture being published, but there it is. Amazing stuff. So that makes me think about the meteor that burned overhead last night at 4-something a.m. And I think where did the fragments go? Did any of the fragments actually fall to Earth? Now, the last thing I heard about the last Saturday morning, I think it was Sunday morning, 22nd of August, I think. No, that's today. Last Sunday anyway. That meteor that burned over Victoria, and its general direction was between Bendigo and Ballarat. As far as I know, they still haven't found any particles or fragments, but I did hear on 774 that Monash University was going to go back out there this week, and they've already covered a fair bit of ground, but they're having another look to see if they can find in other areas. They're expecting something to the size of a football. I don't know. They may find something, they may not. But anyway, interesting to see. Stay tuned, as they say. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, with the official Friday night cast coming from the studios of VK3 CSJ in Narre Warren South. Let's have a quick look at the sky over Heathcote at the moment. There's the All Sky camera, and we can get rid of all those constellations there. So there it is. Now, of course, you might wonder what the red hue is, but that's just because there's no infrared filter on the camera, the All Sky camera. There's no IR cut. CUT on the. Just thought it was something else. So there's a bit of light cloud around, but you can see the Milky Way there. The image, the bottom of the screen is south, and the tree to the right is west. So yeah, but that's the view up at our dark sky site at Heathcote. All right. Next thing I'm going to do here. What have I haven't done that. Yeah, so I've only got a handful of articles here. I've done that. This one here. Where's this one? Where's the one I've got the voice for? Okay, let's go for this. All right. Now, this one I'm using AI again, different female voice, but it seems to work okay. This is courtesy again of astronomy.com. The article is "Our atmosphere is responding differently to solar storms, and satellites will feel the effects. A new study reveals that as carbon dioxide levels rise, the Earth's upper atmosphere will react more dramatically to geomagnetic storms, posing new challenges for the thousands of satellites orbiting our planet." So let me just cue this up. I actually did play that accidentally before, so you would have had a briefness of it. And I'll just make sure that goes back. I'm pretty sure this is it. So stand by, and I've got some graphics. There's a number of pictures associated with this article, so I'll run it as the text is being read out by this wonderful AI voice. In fact, I'll go with the first image here. Hang on, stop that. Right, put that there, and stand by. This is VK3 EKH.
Our atmosphere is responding differently to solar storms, and satellites will feel the effects, Dor. A new study reveals that as carbon dioxide levels rise, the Earth's upper atmosphere will react more dramatically to geomagnetic storms, posing new challenges for the thousands of satellites orbiting our planet. Rising levels of carbon dioxide in our atmosphere aren't just affecting climate on Earth. They could also make weather in space more dramatic, says new research. A team led by scientists from the National Center for Atmospheric Research, NCAR, in Boulder, Colorado, reports that the Earth's upper atmosphere is changing how it responds to energy dumped from space during geomagnetic storms. Their findings, published June 14, 2025, in the journal Geophysical Research Letters, reveal that higher levels of carbon dioxide will make the upper atmosphere less dense overall, but more prone to dramatic increases in density during solar storms. These atmospheric fluctuations can increase drag on satellites in orbit, which could have significant implications for technology like GPS, satellite internet, and spacecraft like the International Space Station. To understand this discovery, it's essential to first understand our planet's atmosphere. It isn't a single, uniform entity, but more resembles a multi-layered cake, with each layer defined by distinct temperature characteristics. We live and breathe in the troposphere, the lowest layer where weather occurs. Above that lies the stratosphere, home to the ozone layer that protects us from the sun's harmful ultraviolet radiation. Next is the mesosphere, where most meteors burn up. Solar storms. When the sun erupts, our sun is an active star that constantly sends a stream of charged particles, known as the solar wind, out into space. Sometimes, it releases massive eruptions of plasma with magnetic fields called coronal mass ejections, CMEs. When these solar outbursts are directed at Earth, they can trigger a geomagnetic storm, a major disturbance of our planet's magnetosphere, the magnetic bubble that surrounds and protects Earth. These storms are powerful events. They can induce intense electrical currents in the magnetosphere and ionosphere, create spectacular auroral displays far from the poles, and pose risks to our technology. Geomagnetic storms can disrupt GPS navigation, damage transformers on power grids, and, crucially for this study, heat and expand the upper atmosphere. This expansion increases the density of the thermosphere. For satellites in low Earth orbit, this is like flying into a stronger headwind. Atmospheric drag is friction caused by a satellite colliding with the sparse molecules of gas in the upper atmosphere. When the density increases, there are more of these molecules in the satellite's path. Each collision, though tiny, slows the satellite down. The cumulative effect of hitting millions of these extra particles creates significant drag. This drag can alter a satellite's speed and altitude and shorten its operational lifespan. For instance, a storm in February 2022 created enough atmospheric drag to cause the loss of 38 Starlink satellites, while the intense storm of May 2024 also contributed to the premature re-entry of several others. A new atmospheric recipe. The composition of our atmosphere is changing, and not just near the surface. While carbon dioxide, CO2, is well known for its warming effect in the lower atmosphere, the greenhouse effect that traps heat and makes our planet habitable, it behaves differently at high altitudes. In the thin environment of the thermosphere, CO2 molecules are more effective at radiating heat back out into space. This means that as CO2 concentrations increase globally, the upper atmosphere is cooling and contracting, leading to a lower baseline density over time. This fundamental shift in the thermosphere's normal condition is what prompted the new research. Scientists wanted to know, how will an upper atmosphere that is cooler and less dense respond when hit by the energy of a powerful geomagnetic storm? To find the answer, the research team used an advanced computer model that connects the layers of the atmosphere, allowing them to see how changes near the surface can influence regions hundreds of miles above. They simulated the powerful geomagnetic superstorm of May 10 to 11, 2024, using atmospheric conditions from a baseline year, 2016, which was chosen because it occurred during the minimum of the 11-year solar cycle. With this baseline established, they ran the simulation again, keeping the storm's intensity the same, but changing the atmospheric conditions to reflect future projections of increased CO2 levels based on standard climate model simulations. They modeled how the same storm would behave in 3 future solar minimum years, 2040, 2061, and 2084. This selection allowed for a direct comparison, isolating the effect of atmospheric changes from the sun's natural variability. The results were striking. Because the atmosphere's baseline density will be lower to begin with, the researchers found that the peak density during a future storm would also be lower, 20 to 50% less dense than what we would see today. However, the most significant finding was the relative change from the pre-storm condition. While a strong storm today might cause the thermosphere's density to double, the simulations showed that in the future, a similar storm would cause the density to nearly triple from its much lower starting point. Although the study used a high-emissions scenario to clearly illustrate this effect, Nicholas Petitella, the study's lead author, tells Astronomy, "The results of our study indicate that even more moderate increases in greenhouse gases would also still impact the upper atmosphere response to a geomagnetic storm." While these predictions are a major step forward, the scientists note that there are still complexities to explore. For instance, rising surface temperatures caused by the greenhouse effect in the lower atmosphere could cause the lower atmosphere to expand. This expansion could potentially offset some of the cooling and contracting effects in the thermosphere. A changing world for satellites? This shift could have profound consequences. While a lower peak density might sound like good news, the greater variability is the real challenge for satellite operators. According to Petitella, the larger relative change in density means that geomagnetic storm impacts will become more severe. This creates a more volatile environment where atmospheric drag can change rapidly and dramatically. For instance, during the May 2024 geomagnetic superstorm, the strongest such storm in 20 years, the increase in atmospheric density caused nearly half of all satellites in low Earth orbit to automatically fire their thrusters in an attempt to stay spaceborne, a study found. Such mass migrations make it harder to predict satellite orbits, as space tracking systems can't keep up with the changes. This increases the risk of collisions with other satellites or space debris. As Petitella explained in an August 2025 press release, for the satellite industry, This is an especially important question because of the need to design satellites for specific atmospheric conditions. More research is needed to fully grasp how different types of storms and the sun's 11-year cycle will interact with our changing atmosphere. But this study makes one thing clear. As increasing levels of CO2 continue to alter the composition of our atmosphere, we are also changing its relationship with the sun and the very nature of space weather.
Well, interesting stuff. And that was courtesy of Miss AI. So I think that came across reasonably well. So I'm fine-tuning all that, but I think I'll continue to sample a number of stories that I see, and I'll add the female voice to the Friday night session as well as Tamitha's. But there's quite a number of voices that I can choose from, and the two tonight were somewhat applicable, but still carrying that slight American twang. So I'm not sure if I'll be able to get away with that any further. But anyway, I hope that came across okay. So that was a recent article on astronomy.com, and I think that was published August 20. All right, I think that's about it. I think there is one more. Oh yeah, this one here. Oh yeah, so I haven't translated this, so I'll have to read it out myself. Damn. All right, this was this just before the space weather. This is called the first supernova of its kind. Now I don't know this image. It's not saying that it's an artist's impression. So I don't know how real this image is. It looks terribly like an artist's impression. I doubt very much whether this is a real photograph. I mean, it's probably a simulated image or something else. But the subtext under the image says that it's SN 2021 YFJ. I think, yeah. It's a new kind of supernova. A progenitor lost its outer shells while before the supernova happened. Unlike any known star in the Milky Way, the dying star experienced extreme mass loss episodes that led to ejecting of material rich in silicon, shown in grey, sulfur, yellow, and argon, purple. Now it says the credit of this image, it says it's from the W.M. Keck Observatory by Adam Makarenko. So it's not saying that it's an artist's impression at all, but this is the image that I'm talking about. vMix, where are we? There it is. So you make of it what you will. But anyway, I'll go into the article. It starts off saying, the first supernova of its kind, a newly discovered explosion reveals the inner workings of a dying star. An international team of scientists led by the Northwestern University astrophysicists has detected a never-before-seen type of exploding star, or a supernova, which is rich with silicon, sulfur and argon. Astronomers long have theorized that massive stars, 10 to 100 times heavier than our Sun, have layered surface, or a layered structure. The outermost layers are made of the lightest elements. As layers move inward, the elements become heavier. When massive stars explode, their spectra typically shows light elements such as hydrogen and helium. But the newly discovered supernova, dubbed SN 2021 YFJ, displayed a surprising chemical signature. The observations suggest it somehow lost the outer hydrogen, helium and carbon layers, exposing the inner silicon and sulfur-rich layers before exploding. And this finding offers direct evidence of the layered structure of stellar giants. This is the first time we have seen a star that was essentially stripped to the bone. A research associate at Northwestern Center of Disciplinary Exploration and Research in Astrophysics, who led the study, He says it shows us how stars are structured and proves that stars can lose a lot of material before they explode. Not only can they lose their outermost layers, but they can be completely stripped all the way down and still produce a brilliant explosion that we can observe from very, very far distances. This event quite literally looks like nothing anyone has seen before, said Northwestern Adam Miller, an assistant professor of physics and astronomy at the Northwestern Windberg College of Arts and Sciences, a senior author on the study. He says it was almost so weird that we thought maybe we didn't observe the correct object. The star is telling us that our ideas and theories for how stars evolved are too narrow. It's not that our textbooks are incorrect, but they clearly do not fully capture everything that's produced in nature. There must be more exotic pathways for a massive star to end its life that we just haven't considered yet. Massive stars are powered by nuclear fusion, where extreme pressure and heat in their cores causes lighter elements to fuse, generating heavier elements. As the star evolves, successively heavier elements are fused in a series of shells surrounding the core. The process continues, eventually leading to a core of iron. When the iron core collapses, it triggers a supernova. Although a massive stars typically shed layers before exploding, SN 2021 YFJ ejected far more material than scientists had been ever detected. Other observations of stripped stars have revealed layers of helium, carbon, and oxygen exposed after the outer hydrogen envelope was lost. But astrophysicists had never glimpsed anything deeper than that, hinting that something violent must have taken place. Schultz and their team discovered SN 2121 YFJ in September 2021 using Northwestern's access to the Ziki Transient Facility, ZTF, located just east of San Diego. ZTF uses a wide field camera to scan the entire visible night sky. Since its launch, ZTF has become the world's primary discovery engine for fleeting phenomena like supernovae. After looking through ZTF data, Schultz spotted an extremely luminous object in a star-forming region located 2.2 billion light-years from Earth. To gain more information about the mysterious objects, the team wanted to obtain its spectrum. The spectrum came from an astronomy colleague who captured it using an instrument at the W.M. Keck Observatory in Hawaii. Instead of helium, carbon, nitrogen, and oxygen found in the spectra of other supernovae, N2021 YFJ spectrum was dominated by strong lines of silicon, sulfur, and argon. These heavier elements form as shells around the core during a massive star's final stages of life. The star lost most of the material that it produced throughout its lifetime, Schultz said, so we could only see the material formed during the months right before its explosion. Something very violent must have happened to cause that. The science team is exploring possible reasons, including interactions with potential companion star, a massive pre-supernova eruption, or even unusually strong stellar winds. But most likely, this mysterious supernova is the result of a massive star literally tearing itself apart. As the star's energy output lessens and the gravity can then shrink it, the core becomes even hotter and denser. This reignites nuclear fusion of heavier elements, creating powerful bursts of energy that push away the star's outer layers. Each time the star undergoes a new episode, the corresponding pulse sheds more material. One of the most recent shell ejections collided with pre-existing shell, which produced the brilliant emission that we saw in SN 2021 YFJ. While we have a theory of how nature created this particular explosion, Miller said, I would bet my life that it's correct, because we still only have one discovered example. The star really underscores the need to uncover more of these rare supernovae to better understand the nature and how they are formed. So look, I don't know exactly how real that image looks or is, but it's not an artist's illustration, and the clarity of it is what gets me. I might see if I can investigate a little bit more into that image and just see what exactly we're looking at. Anyway, very briefly, spaceweather.com says that, and let me bring up our sun. Our sun, where is our sun? Come here, sun. There it is. There's a black cat wandering around behind me there, you might have noticed. Okay, that's the current sun. If we could look at the sun directly with protection, that's the number of sunspots that are on the sun, very much less than how it's been over the last 12 months. But Space Weather reports that the solar wind is currently at 494.9 kilometres a second with a density of 1.14 protons per cubic centimetre. The current sunspot number is 76, while the radio sun is 121 solar flux units measured at a wavelength of 10.7 centimetres. The aurora is very vague at the moment. This is the current, I'm just looking at my geochron. It's about the same. This was the current image about an hour ago of the southern aurora borealis. No, sorry, australis. Oh, God. The aurora over the Antarctica. And as you can see, there's not much to write home about there. Australis. And the coronal, yep, that's the latest image of the coronal holes, which are at the top part of the image there. Those what look like the eyes of the sun, they refer to as coronal holes, which are areas where intense streams of solar wind flow from. The current KP index is 1.33, considered quiet. And there's a image here from the SOHO satellite of a CME, which is just going right now. I'll loop it so it continues to go. Righto, there it goes. And the latest, where are we? The bright far side CME, fast-moving CME, coronal mass ejection, blew away from the far side of the sun, forming a complete halo around the solar disk. The Solar and Heliospheric Observatory, or SOHO, recorded the explosion, which is what you see on the screen there. I don't think there's much else to report there from Space Weather. There's a lot to read, but generally that's it. As of August 22, there were 2,349 potentially hazardous asteroids. Occasionally, some fall through a roof in the ceiling. Anyway, enough of that. All right. I've managed to fill up an hour, surprisingly enough, but there it is. We've gone through an hour. All right, this is VK3EKH, the official station for the Astronomical Society of Victoria. We shall now take a quick callback. Is my pen working? Yes. And we shall see if we can... Yep, okay, I know what's going on. See if there's any stations. This is VK3EKH listening on 3541. All right, VK3 Delta X-ray and VK3 KIS. Any other stations? Boy, oh boy. I drove everybody to sleep. All right, let me just take the headphones out of the socket here. And kill that. And okay, so all right, VK3 Delta X-ray, VK3 EKH. Have a say, Greg.
And watching on YouTube there too, saw the big black cat lurking in the shack there, and yeah, the AI was interesting there, Clint, come through quite well, and it's all good. I'm going to bed tonight, mate. I'm going to put the Faraday cage up to protect me from those meteorites. And maybe everyone else has gone there to do likewise, to not reinforce their roofs. Interesting broadcast, Clint, as it always is, and thanks for rowing it, mate. You do a great job each week. And keep up the good work there, Clint. We look forward to it. VK3 EKH, VK3 Delta X-ray, Greg in Warrnambool. Signal 59 plus 20, Clint.
Yeah, thanks, Greg. VK3 Delta X-ray, VK3 EKH. Yes, likewise, your 2025 over 9. The quick view of the S meter there, and yeah, we can either build a protective house with thick layers of metal. I often wonder. I often hear things. I've got corrugated roof. And I often hear things hitting that roof at night time. I think it's the possums. I think the possums launch themselves from a high branch and go crashing onto the roof. It's a very loud sound. And by the time I get out there with a torch, there's no evidence of what it was. So, but I do often wonder about small meteor fragments making it like a bullet making its way through the corrugated roof. It could happen. Anyway, there it is. All right, thanks, Greg. Excellent stuff, and thanks for the comments. Okay, it's across to Andrew. Good signal at the moment, Andrew. VK3KIS, VK3EKH.
VK3 EKH, VK3 EKIS. Good evening, Clint, and all listening in. Just been doing a lot of work on the TS2000. Not me, but another amateur. And we finally figured out what the problem was. The RF in the shack and the bad signals and so on. It turned out to be a faulty lead, but actually that the end at the radio side was intermittent. Once we swapped that out and gave the radio a little TLC, it was happy. So hopefully you can hear me now. After all these years of trying. VK3 EKH, VK3 KIS.
Well, yes, I can definitely hear you perfectly well, Andrew. It seems like you've